Welcome back. We just learned about this pillar of functional programming, the idea of a pure function, where we have no side effects and the same input, no matter how many times we call it, gives us the same output. But I posed a question for you, whether we can do anything without side effects. Because, as I said, console.log, well, that's a side effect. As a matter of fact, input-output is a side effect. That is, communicating with the outside world in any way, which is what input-output is, that is not pure. And the interesting thing is that with just pure functions, which are just functions that do something on the inside and the outside world knows nothing about, is philosophically, well, it doesn't do anything. Because a program cannot exist without side effects. We can't run this piece of code without having a side effect of interacting with the browser. We can't have websites with just pure functions, can we? Browsers have to make fetch calls, HTTP calls to the outside world. We have to interact with the DOM and manipulate what's on the website. So the goal of functional programming is not to make everything pure functions. The goal is to minimize side effects. The idea is to organize your code where there is a specific part that has side effects, but when you have a bug, you know right away to go to that spot because that's where the side effects are happening. The rest of your code, well, those are just pure functions, and because they're pure, we don't have to worry about them as much. Purity is more of a confidence level. It cannot be 100%. So if there's one thing that you take away from this, is that side effects and impurity is not necessarily bad, but the goal is to organize your code in a way so that you isolate these side effects, these database calls, API calls, input-output to a certain location in your program, in your code, so that your code becomes predictable and easier to bug. Because at the end of the day, we do have to have some sort of a global state to describe our application. That's unavoidable. This is just the tip of the iceberg. When it comes to terminology in functional programming, it gets really complicated. And there's some really large words like referential transparency. But as I said before, at its core, the essence of functional programming is very simple. We want to build programs that are built with a bunch of very small, very reusable, predictable, pure functions. How do we build the perfect function? We're going to explore that over the next couple of videos, but this is a quick reference. A perfect function should do one task and one task only. We don't want a massive function, a simple function that we can test that does one thing really well. That function should have a return statement. Every function should return something from it, because when we give it an input, we expect an output. Every function should be pure, which we've talked about. And that also means having no shared state with other functions and immutable state, where we can modify some of the state within our functions, but we always return whatever we get, such as an input, we always return a new copy of that output. We never just modify our global state. Functions are also going to be composable, something that we're really going to dive deep into later on. And most importantly, we want to make functions predictable. If we understand with 100% certainty what our functions do, it makes our code predictable. Functional programming, at the end of the day, is just about making your code predictable. Let's dive in to some key concepts and key words when it comes to functional programming.